Okay, madam, start.
Today I am going to teach design and analysis of algorithms. In that subject I am going to teach minimum cost spanning tree. So before we are going to discuss about the minimum cost spanning tree, we have to discuss what is meant by spanning trees. What is meant by spanning tree? The spanning tree is a subgraph of the given graph is called spanning tree. The spanning tree means the subgraph of the given graph is called spanning tree. Let graph vertex comma edge be an undirected connected graph. A subgraph T is equal to V comma E power I of G is a spanning tree of G if it is a tree. A tree is a connected undirected graph that contains no cycles. What is meant by tree? A tree is a connected undirected graph that contains no cycles. So what is meant by spanning tree? The spanning tree is a subgraph of the given graph is called as spanning tree. So now see what are the different properties we have to discuss about a spanning tree. The first property is it should contain all vertices of the graph. We have to check the graph contains all the vertices of the given graph or not. The second property is that graph contains n vertices, then a spanning tree contains n minus 1 edges. So here we have to discuss about n minus 1 edges. Suppose if the graph contains 4 vertices, the spanning tree contains n minus 1 edges. It means that 4 minus 1. It means 3 edges contains the spanning tree. So here second property is that a graph contains n vertices, then a spanning tree contains n minus 1 edges. The third property is spanning tree should contain any cycle. We have to check the spanning tree should contain any cycles or not. So any spanning tree should satisfy all these 3 properties. First property is the spanning tree contain all the vertices of the given graph or not. The second property is that a spanning tree contain n minus 1 edges or not. The third property is a tree should not contain any cycles or not. We have to check. These are the 3 properties in the spanning tree. So this is the example of the spanning tree. Here we have the graph like this. Now check what are the different spanning trees we have to draw by using this graph. So here these are the different spanning trees will be formed from the above graph. So this is the main graph. What are the spanning trees we have to form by using this graph? Here we have to follow the 3 properties before we already discussed. So these are the 3 properties of the spanning tree. The first property is that tree contain all the vertices in the given graph or not. Now we have to check the first graph. So this is A, B, C, D, E. Here all the vertices of the given graph are existed or not, we have to check. Here we have A, B, C, D, E. So in this graph all the vertices A, B, C, D, E, all the vertices are existed in this particular graph. And the second property is, see here, it is a graph contain n vertices, then the spanning tree contain n minus 1 edges. Now see n minus 1 edges. How many edges are existed in this graph? 1, 2, 3, 4, 5 and 6. See here in this we have n minus 1 edges. 1, 2, 3, 4. So here we have now see here we have 1, 2, 3, 4, 5, 6. So here we have the graph called n minus 1 edges. 1, 2, 3, 4. But here we have 6 edges, here we have only 4 edges. So this is not the spanning tree.